Hello ECM Podcast 的听众朋友们，大家好。这一期 Podcast 是非常特殊的一集，是我们策划的去中心化 Rollup 系列的第一集。我们首先呢会在开头聊真正的 Rollup 应该具有什么样的特性，以及应该从哪些方面去判定一个 Rollup 的安全性。这期节目呢会使用英文进行讨论，那么在底下的 Notes 栏里会有本次对话的中文转译文本。这次的嘉宾呢，我们很荣幸邀请到了来自 Arbitrum 的Patrick McCorry. Okay, the Chinese introduction is done. So what we are going to explore in this episode is what does it mean to decentralize a rollup? Why does it matter? So, and what are the problems they are going to solve? So we are going to break into several parts and walk through them to finally understand what will define a real rollup and what goals they should satisfy before they can claim that they are secure and decentralized. So why don't we get started with introducing yourself, Patrick?
Yeah. Hi, everyone. So my name is Patrick. I guess historically speaking, I was an academic. So I did my PhD in both Bitcoin and Ethereum from 2013 to 2016. And then from 2016 onwards until about 2019, I was a researcher at the university. So I was at UCL, King's College London, and UIUC. And during that period, I was always really interested in layer 2 protocols. So that includes both the Bitcoin Lightning Network and then Plasma, and of course, rollups. Around 2019, I tried to do a startup. So I left university, me and my friend, basically two people and a dog. We tried to do a startup, and it was focused around layer 2, but it was the bear market. And so eventually we got acquired by Infura. And then I left Infura and I recently joined the Arbitrum Foundation. So really going back to focusing on rollups full time. And just throughout that entire period, I tried to focus on education to really explain why are rollups useful, why should we care about layer 2 protocols. So sort of like a bit of an academic background alongside some experience in industry, but I always call myself an intern in industry because my skill set never applies.
Okay, so thank you, your introduction. So I knew that you wrote a few papers about L2 and several papers, though I didn't read it all because it's very very long. So but it's a very good opportunity to talk with you to tell all the people that what should we care about decentralized rollup. So about in the topic one, so generally speaking, what is a L2 system? So what does it mean when users deposit money into L2 system and do transaction there?
Yeah, I think it's even better to step back a bit and just consider, what's the point of a blockchain? What's the point of all these systems that we're trying to build? And then once we explain that, hopefully L2 will make a bit more sense. So when you think of a blockchain network like Bitcoin or Ethereum, what's really behind the hood is just a database. There's a public database that anyone can read and anyone can write to. So it's a database of account balances. And of course, in Ethereum, you have account balances alongside programs. So I can deploy my code onto the database, my program can have some state, and of course I can transact and everyone can see how the database has been updated. Fundamentally, we're just working with databases. And it's really boring because databases are really boring. And the point of the blockchain itself, the blockchain is really just an audit trail. So it stores a list of transactions. And if I give you a copy of a blockchain, you can recompute the database yourself. And so fundamentally, that's all we're building. We're building a public database that anyone can read, anyone can independently compute, and anyone can write to. So that's the base level. Okay, so that's layer 1. Now, the problem of layer 1 is, with both Bitcoin and Ethereum, is that we really want to maximize what it means to be decentralized. And there's 3 different ways you can think about decentralization. One is, the operators, who's running the network, who's producing blocks, and who's confirming transactions. And really, for a lot of these networks, you want to maximize who can participate in that process. Who can be a miner, who can participate in the proof of stake protocol. We want to maximize the operators so there's no single point of failure. On the other side of it, the other aspect of being decentralized is also considering who can, verify every update to the database, who can verify that the operators are doing their job and the database is correct and valid at all times. And at that point, you have this sort of contention. You want to maximize who can verify that the network is correct and running appropriately. And you want to also maximize who can participate and, operate and run the network. And so that's sort of like the old Bitcoin block size wars. We have big blocks, we can process more transactions, but then it's more difficult for, you need more hardware in order to verify the network in real time and to also be an operator. So that's sort of, what it means to be decentralized in a layer one context. And also the third part actually is to make it affordable. If you want to transact in these networks, I used to make a joke that it would cost like a penny to transact on Ethereum and then it would be $10. But as we've all seen recently, it could be $100, $200 to transact on Ethereum. And if you're building networks where it costs $200 to transact on a network, then is it really decentralized? And obviously it's not. So you have this historical trilemma in a sense. Operators who run the network, verifiers, which could be anyone in the world who wants to keep track of this database and make sure that it's correct. And finally, the users. Can we make it affordable for people to transact on the network? And for a very long time, we were stuck with this trilemma, because if you tried to process more transactions, one of those parties would get hurt in some way. Either the fees go up, the hardware requirements go up, or it's more difficult to be an operator. So that's like the L1 context.
Okay, so as you said, so when considering transaction costs for user, they may deposit their money into a centralized exchange. So I think is that kind of a kind of L2?
I think that's a good way to consider it. So when you consider like an exchange, it's again just like a database.
Yes.
But the problem with an exchange is that it's a private database. It's not so basically when you consider an exchange, you have this database that only the exchange can read and only the exchange can write to. And users like you and me, we can't audit that database. We can't check that it's correct. But what's nice about using an exchange, as most people could probably confirm, is that transacting there is really cheap. I go on Coinbase, I log in, I deposit funds in the Coinbase, then of course I transact there, and it's basically very low fees and nearly cheap for me to do that. But then that's the trade-off. So you have these layer one blockchain systems that are aiming to be as decentralized as possible, but the problem is the throughput. The fees are too high. Then you have this other extreme, which are these custodial exchanges, where you could argue that probably 99% of all transactions really happen, but they're fully trusted, they're opaque, but the fees are really low, and that's really nice for the users. So when we think of the L2 world, in the L2 world, we don't really want to recreate L1. We don't really want to have to build a decentralized network that maximizes the number of participants, because we already know historically it's very hard to build those systems and then make them scale in terms of throughput. So the question is, when you think about L2, can we build a system that looks like Coinbase or Kraken or OKCoin, any of these centralized exchanges? Can we build a system that looks like an exchange, but still retains the properties of a blockchain system, where the database is public? So anyone can read the database, anyone can write to the database, and anyone can step up to protect the database. And so that's sort of the goal for L2. And what's really nice is when you get under the hood, so when you compare the exchanges to what we're building in L2, what it really comes down to is the bridge. And it's really just bridge engineering. And what I mean by a bridge is that on Ethereum, there'll be a smart contract, and I'll lock my assets into this smart contract called the bridge. Once it's locked into the bridge, it will then appear on this other database. The database could be Coinbase, it could be Arbitrum, it could be Optimism. At the end of the day, they're just databases. Once I lock the funds in the bridge, they'll appear on this database. And then the question is, when I want to take my funds from this other database and bring it back to Ethereum, how does that get authorized? And how does the bridge be convinced that it's you to unlock the funds? So for Coinbase, you just trust Coinbase to make the authorized withdrawal. The smart contract will check that and say, oh, Coinbase authorized this, I can take the funds out. But for L2, it's really, the focus is really on the bridge and how it can be convinced that this off-chain database is okay, well, secure, safe, before it allows funds to get released. So it's just, he's just winding back a bit. I think if you consider Coinbase at all, or these exchanges, they're basically what we want to build for L2. But we want to build it in a way where it protects the user. So if Coinbase goes offline, or if they're malicious, or they're hacked, the user is always secure and safe. They don't have to trust the operator of the system. So maybe that's a good way to summarize the goal. And it's really focused on the bridge of how the assets get locked into that system, then get taken out of that system. That's sort of the goal of what we're building in engineering.
Okay. So I think what roll-ups are trying to do is just do some trade-offs. They just like so what kind of weapons they are using to secure users? I think the bridge is one of them.
Yeah, well, I think it's really the focus is the bridge itself. So if you consider the Arbitrum bridge, it's a suite of smart contracts that live on Ethereum. And today that bridge holds about, I think it's like $6 billion or something. So it's really a set of smart contracts on Ethereum that are holding $6 billion. And the bridge needs to be, you need to convince the bridge that, oh, I'm entitled to take my funds out of the bridge and back onto Ethereum. So what are the weapons we have for that? So what's really nice about the L2 world is that we can make a very nice assumption. We can assume that there's an L1 out there already, like Bitcoin or Ethereum, that already exists and works. We can already assume there's this decentralized platform that we can build upon. And we can consider this platform as a trusted third party. We just assume that this party out there that we can trust, who will always do the right thing. And so that's sort of the basis for all of these systems. If you have this nice decentralized platform, you can leverage that and reuse that and build on top of it. And you just assume it's like a box, and it's just, it exists, it's nice, it's really a really nice, trustworthy party that we can work with. And so when you're designing these type of systems, if you can assume there's a third party you can trust to do the right thing, then you just have to design around that. So then the problem statement really becomes, we have this off-chain database that records the account balances, the program state. And so can we use the trusted third party to check that every update to that database is correct and valid? And that's really what L2 is all about. And so as a concrete example, if you consider Arbitrum, you have this Arbitrum database, it has the account balances, the program state. Then you have the smart contracts for Arbitrum, the bridge that lives on top of Ethereum, and Ethereum's that trusted third party. And it guarantees that bridge will always run correctly. And so periodically, what will happen is that people who are running the Arbitrum network, the sequencer, the validators, they'll periodically send, checkpoints or evidence to the bridge, and they'll periodically convince the bridge that an update applied to that database was correct and valid. And if the bridge is convinced, it will then allow users to withdraw their funds from Arbitrum. And so that's sort of the weapons that we have. We have this nice trusted third party. You'll always do the correct thing. And all that trusted third party, now if we have that, our main weapon is leveraging that trusted third party, which is this decentralized platform, just to check that every update to the database is valid and correct. So again, it's really boring. We have this off-chain database, and all we're really doing is checking that every update is correct before the funds can be released.
So you just said that Rollup is building on top of Ethereum. So it reminds me of a saying that the community is always saying that Rollup inherits the security of Ethereum. So is that means the security of Rollup equals Ethereum's? So I think we can break into several parts.
No, of course. I think that's a great way to think about it. So
yeah.
So yes and no. I think there's different ways to think about it. So when we think about security, there's two different ways we can break it up. The simple way is safety and liveness. Safety is pretty much saying, and we just consider this in the database. Okay, we have this database, and if we have safety, we're basically saying that every update of that database is valid. There can never be an update that's invalid, because if there was an update to the database that's invalid, then you could just steal the coins. You break safety, you break the fundamental security, and you can steal all the funds from the database and the bridge. And that sucks. That's one big part of this, when we say we inherit security from Ethereum, What we're really saying is we're trying to inherit that safety property. So we can always guarantee that every update to that database is correct and valid. The next part is liveness. And liveness really comes down to, can we make sure that people can make updates to that database? We have this database out there. Of course, that's the Arbitrum network or the Optimism network, whatever. But there's a database fundamentally. And for liveness, we need to guarantee, can we always make updates to that? Or can there be one honest party out there who comes along? They can register for the system, they can propose an update, and that update eventually gets processed. And that's important because let's say if Coinbase goes offline or Kraken goes offline, if they go offline, then your funds are stuck. And that's nearly as bad as a safety fault, because if my funds are stuck, well, I can't get my funds out. So that's terrible, isn't it? So for rollups, this is how it's slightly different to Ethereum, because in Ethereum, you have to trust the proof of stake protocol on an honest majority to keep the system alive. On a rollup, we already assume we get that for free. We assume Ethereum exists and it's working. So in a rollup, we just assume that there's one honest party out there. As long as there's one honest party who's willing to do the work and propose an update to the database, then, of course, the system can remain alive. So that's what we mean by inheriting security from Ethereum. It's really about the safety property, that all updates are valid, and the liveness property. That one honest party out there, this could also be you, by the way, if you want, if you're willing to run the software, you can come along, step up, propose an update, and make sure that transactions always get processed, and eventually withdrawals can be processed as well. So that's one angle to the security idea. And then more concretely, we need to think about the bridge itself, because I already mentioned the bridge is a smart contract that lives on Ethereum, and the bridge, which we call a validating bridge, holds around $6 billion of assets for Arbitrum at least. And so the bridge is the sole authority that can decide whether funds are released back to users. And so when we think about the security of a rollup, we're not really thinking about a decentralized network out there. There may be a decentralized network out there, but that doesn't really matter. The security of a rollup really depends on that bridge. It's a smart contract that needs to be convinced about three different things. The first one's data availability. That's the data availability problem. And really what that's saying is the bridge convinced that anyone in the world can get access to that database? That anyone in the world can recompute a copy of that database and an up-to-date copy of that database? So that's the first thing you have to convince the bridge about. Can anyone in the world get a copy of the database that we care about? The second property, which you could call the state transition integrity problem, and that goes back to safety. The bridge needs to be convinced that every single update to that database is correct and valid. And that's to make sure nobody can steal your funds. And so periodically, the operators of Arbitrum or Optimism, they have to periodically convince the bridge about every update that has been applied to the database. And only then will the bridge release funds, or withdrawals that should be processed. Then the final one's censorship resistance. And it comes down to that liveness idea. If the entire system goes offline and no one's around to update the database, can someone come along and, of course, propose an update to the bridge or propose an update to the database that is then processed by the bridge. So it's maybe just to summarize that, when we think about security for a rollup, it's really from the perspective of a smart contract on Ethereum, the bridge contract, and it's up to the bridge to be convinced that every update to that database is valid and correct. It's not really about a decentralized network. We just assume there's one honest party who will help the bridge to protect the assets that are locked there.
So also I remember that you made a metaphor in one of your articles that is about a movie, The Law of the Rings, right? Gandalf to be the one who fight against the adversaries, right?
The adversary, yeah. I think it's called Bogle or something.
Yeah. This metaphor is great. So can you explain more about this one honest party who being the hero to fight against all the malicious parties?
Exactly. Yeah. So I think Gandalf's a great example of that, because in the
Yes.
scene he's literally standing on a bridge,
I love
bending
this
off against a
movie.
shooter. Yeah. And
Okay.
the quote of me says, you shall not pass. Then he destroys the
Yes.
bridge and the adversary falls through. Then later on, he kills the adversary on top of a mountain somewhere. He's the one on his party, steps up and protects the fellowship. And it's exactly the same here. So, like as I mentioned, so the bridge contract is ultimately responsible for protecting the assets that are locked into this off-chain system. That could be Coinbase, Kraken, or of course Rollup. This was what we really care about. The one on his party is an assistant. So it's a bit like the fellowship in a way. Gandalf was the assistant to the fellowship to make sure the ring could then be destroyed. And in this case, it's exactly the same. The one on his party is helping the bridge. So the bridge, the smart contracts, they live on Ethereum. They can't really interact with the external world. So they need someone who will come along, look at the off-chain system, in this case could be Arbitrum, and the relay messages between the Arbitrum network and the bridge sitting on Ethereum. And so that's what the one on his party does. They just take messages from that network and they relay it to the bridge. And then they convince the bridge, or at least they try to convince the bridge that this is correct. If there was a malicious party out there, let's just say the Arbitrum network was corrupted and all the validators are evil and they want to steal all the funds from the system. That's not a great scenario, is it? But if that were the case, because Arbitrum relies on fraud proofs for yes. safety, anyone around here can come along. So for you, for example, you could turn on your computer, you could stake funds into the contract eventually. And then, of course, you could send a message to the bridge to say, wait, bridge, there's a problem. The operators are cheating. The operators are trying to steal the funds. Here's evidence of their fraud. Don't accept that database update. And then the bridge will say, oh, no, wow, here's the operators giving me evidence. Here's an honest party giving me evidence. The bridge can independently evaluate that and say, yep, the honest party is correct. The operators are evil, /// kick them off the system. And then, of course, protect the funds that are held there. So there's just an assistant. They watch the Arbitrum network, or they watch the Rollup network. I shouldn't necessarily just say Arbitrum. They watch the Rollup network. They look out. Anyone can do that. Anyone can look out for fraud or bad actions by the operators. Then they can step up, assist the bridge, and of course, protect the system. And that's why it's really exciting.
Okay, so I think this is about the state transition integrity. So as you say, Arbitrum use a fraud proof system, so they already have those assumption that there to be a one honest party. So what about the other type of roll-up? They use validity proof. So
validity proofs, exactly.
So
yeah. So
who would be the honest party in this kind of roll-up?
So maybe this is the odd context to the listeners. So as we mentioned already, is the bridge contract is responsible for checking every database update that's applied to the database. Now, an honest party or relayers or anyone can submit a database update to the bridge, and they should also provide evidence that this database update is correct. And that's all we're trying to do here. We're just trying to convince a smart contract that an update to the database is valid and correct. Then it should be accepted and processed. And there's two ways you can do that. There's two different types of evidence. So one is a fraud proof, and that's implemented by Arbitrum currently. And the idea is that anyone can come along, submit a potential update to the bridge, and they can attest to it. They can say, bridge, here's an update to the database. I attest to the fact that this is correct. And now there's a 2-week period for anyone to come along and to challenge that. So you could, if let's just say I propose an update to the bridge and I stake on that and I say, bridge, here's an update to the database. I promise you that is correct. You could watch that and you could, basically independently check that I'm wrong. And you can independently look at what I did with the bridge. You can say, no, Paddy's lying. That's not a correct update. So then you can register for the system and then you can challenge me. And then what will happen is that the bridge will coordinate this fraud proof game where we go back and forth till we find a very small state transition that we disagree on. Then the bridge will independently check that and it can work out who's at fault. So that's how the fraud proof system works. The disadvantage is that there's a 2-week period or a 1-week period because you need to provide enough time for a challenger to step up and to protect the system. In a validity proof system like the ZK rollup, so this is sort of like StarkNet, ZK Sync, Polygon Hermes, Scroll, Tyco, etc. They don't have any fraud proof game there. The idea is that when a user or an operator submits the database update to the bridge, they also provide a validity proof, which is, well, it's not even a zero knowledge proof, but it's the same idea. It's a validity proof. And they're basically providing a mathematical proof that beyond all reasonable doubt that this database update is correct and valid. You know, it's actually magic as wizardry in a sense. You know, it's basically saying, here's an update, and here's a tiny proof that's mathematically secure to say that this update is correct and valid. And it's impossible for this not to be valid. Or at least it's not impossible, it's like negligible. It should be probabilistically impossible to break this. And it's really nice, actually. It's a very strong property because then I submit, you know, anyone can submit an update to the bridge with the proof. Then the bridge can be convinced immediately that the update is correct and valid, and then simply process it from there. So there's two different approaches to this. And just to give you pros and cons, because I think that's always important, the fraud-proof approach is nice because if you're running the system, all you have to do is execute the transactions, execute the database update, and then, of course, apply the update to your database. The downside is that there's a 2-week period or 1-week period because you need a challenger. You need to provide time for a challenger to step up and to protect the system. In a validity proof, the obvious pro is that once you create a proof, it's immediately accepted. The bridge can accept it and then, you know, process any withdrawals after that point. The disadvantage is that not only do you have to execute the transactions, you update the database, you also have to create this proof that the execution was correct. And that proof is one, it can be very expensive to actually produce. Maybe we could talk about that later. You know, it's computationally expensive to produce, even though the cost is coming down, and it takes a while to do as well. The other problem is you have to design your virtual machine to support computing the validity proof. And we're getting to the stage now where those virtual machines can be very expressive and they can look like the EVM, but there's a lot of wizardry happening under the hood. And it's also very difficult to audit and to verify that it's doing the correct thing. So there's like the two pros and cons. So hopefully long-term validity proofs become mature enough where there's just a default option. But fraud proofs are still very useful, at least in the medium term, because they're very easy to reason about and they're optimistically cheap. You know, that's sort of the benefit to it. But again, there's just solving that one problem. Is an update to the database correct? And that's it. You know, you still have the censorship issues, you still have the data availability issues. You know, can we make sure anyone can get access to the database? They only solve that one small problem. But of course, it's the most interesting problem, so everyone wants to talk about it.
Okay. So as we discussed above, so what makes a rollup different is that it has a mechanism to fight against the adversary, but still we can see many trusted and permissioned parties inside a rollup system. So how do you see this the progress of decentralizing rollups? So what's the most important goal of it, and what should we decentralize as soon as possible?
Yeah. Maybe a good way to think about this as well, again, think about exchanges like Coinbase, Kraken, etc. So if you think about these entities, you know, behind the scenes, they have a sequencer. I log in the Coinbase website and I give them my transaction. The sequencer will take my transaction, decide the order, then they'll pass that on and it'll, you know, to the server side, and they'll get, you know, processed and updated by the database. So that's the current architecture of these exchanges. You know, they're very centralized. But under the hood, you have the sequencer who takes users' transactions. They then pass it on to the server, where it then gets, you know, it applies it to the database and it gets updated. Now, the problem with this entire process is, again, that it's OP, gets trusted. We have no insight that what the hell is going on there. We have to fully trust this entity to protect billions of dollars. And you're relying on human processes to protect billions of dollars, and that sucks. You know, we don't want to rely on humans to trust money because humans aren't very good at enforcing rules.
Yes.
You know, we're just not very good at that, are we? So on the Rollup side, what we really want to do is try to replicate that. And so in Rollups, you replicate, the architecture, but make it more transparent and auditable. And of course, we can all check that it's running correctly. We rely on software to enforce the rules and not humans. So with that in mind, when you think of a Rollup, there's two different parties we really care about. There's the sequencer, and their only job is to have a user-facing website or interface or API. They take users' transactions, they decide the order of execution, and then they pass it on. They could either pass it on to the bridge smart contract directly on Ethereum, or they can just pass it on to a set of executors. The executors will take these transactions, execute it according to the order, they'll create a database update, and then they'll propose that to the bridge. And they'll say, bridge, given that list of transactions, here's an update to the database. Okay, so with these two different actors, this is really when it really comes down to what does it mean to be decentralized. Okay, so, and as I mentioned already, for a Rollup, we just have to assume there's one honest party out there who can protect the system. So the question is, where is that honest party? Is it a sequencer or is it an executor? Mm-hmm. So what's really nice about the Rollups is that the sequencer who takes users' transactions, it's optional. You don't actually need a sequencer. The sequencer is just there to provide a nice user experience where you get this nice promise where, I send a transaction, I get an instant confirmation that is confirmed. The reason for that is that the bridge contract sitting on Ethereum is ultimately responsible for the ordering of transactions. The bridge will decide the final order of transactions to be executed. So any user like you and me, or any smart contract even, we can just take our transaction that we want to execute on the system or to the off-chain system, and we can send it directly to the bridge. So I take my transaction, I send it on Ethereum, it hits the bridge gets it, and then the bridge will eventually order this for execution. So what's nice is that because we can trust the bridge to always do the right thing, we don't care about the sequencer. The sequencers trust it, but they're optional. They're only there to provide a good user experience, but not really to protect the system.
But sequencer is a fast path for users to transact, right? Okay.
Exactly. Yeah, they provide the fast path. So if you consider it like fast and slow lane or slow path, the sequencer provides the fast path. They provide a promise that it will be executed and that it will be ordered. But no one's really tied their hands. They're not forced to do that. It's just a promise. And then eventually, once it gets ordered for execution, and then, so I guess it's like the tiers of finality for a transaction. Maybe this is a good way to think about it. I give my transaction to the sequencer. That's a promise. I know how it should execute, but it's a promise and there's no guarantee. When that transaction gets ordered for execution, and the bridge is aware, the smart contract on Ethereum, once it's finalized the ordering of execution, anyone in the world could execute those transactions, and anyone in the world can compute a copy of the database, and anyone in the world can check, yep, this is how my transaction will execute. But it's not yet executed. It will eventually be executed. Then the executors come along, they take the transactions, they execute it, then they propose an update to the bridge to say, bridge, this is how the database should be updated according to the transactions that you've ordered. And so they're like the three tiers of finality. Only once it's been ordered for execution and then it's been executed, will the bridge then perform any side effects, for example, allowing users to withdraw their funds. So that's sort of the tiers of finality there. But I guess the original question was, where's the honest party? So we know that the sequencer doesn't really have to be honest. And it doesn't have to be a large set of parties either. It could be one party, 3 parties, 5 parties. What you're really trying to secure there is that fast path. But it's more optional. It's more about, can we make sure that anyone can use the fast path and not just certain people in the world? The second part is about the executors. And that's really taking the order transactions and executing them. And that's where we need to worry about decentralization. But decentralization here is very different to how we think about it on layer 1 blockchains like Bitcoin and Ethereum. It's not really about maximizing the number of participants actively. It's not really about maximizing the active number of participants. On Ethereum, we have 500,000 stakers, at the protocol level. we don't need that many people to be an executor on a rollup, because all we really need is one honest party. So decentralization there is really saying, can the system be open enough to allow one honest party to step up and protect the system? It's not really about saying we have 500,000 executors. If anything, that's wasted resources. So decentralization there is really about, can we make sure there's one honest party who's available, and setting the threshold appropriately so we get the correct honest party to stand up, and we just don't get spammed or have bad Siebels, attacking the system from there. So that's probably one aspect. That's probably like, if we consider about how to decentralize the live system, we just care about one honest party. But I think there's a second part that maybe we'll allude to shortly, which is really about governing the network. How do we come together as a collective to decide how the system can be upgraded? How can we collectively work together to say this software upgrade to the smart contracts or to the off-chain components, how can we collectively agree that this upgrade should be done? And that's a whole different ballpark of decentralization. That's more of a governance problem. How do we govern this system to make sure that upgrades are proposed to the system? And that's where you probably want to maximize participation. So that's like a DAO, for example. What's nice about a DAO is that if you're a token holder, you have a governance token, and you can now vote on how you upgrade this system. And that's also really cool. So I guess just to summarize that, there's two aspects: decentralization of the live system itself. And there you just want one honest party or one honest executor. That's the fundamental baseline assumption that we go for. And then we have to think about governance of the system and governance of software upgrades. And that's where you have the DAO. That's like the human intervention part. Sometimes we need humans to come in and decide upgrades. We need a DAO or someone or some way to reach agreement on this that maximizes this, the participants or who care about the system.
So on the governance side, do you think removing the upgrade keys is the final goal to decentralize the governance?
Yeah, well, I think maybe just to give context for listeners as well. So if you think about a live deployment of a system, the question is, how do you upgrade this? So one could be an admin key. You assume there's an admin out there. They have the exclusive privilege. They upgrade the smart contracts based on how they see fit. The second approach is more like a multi-sig. Instead of one party, can we trust, 5 out of 9 parties or 9 out of 12 parties? If we have this distributed set of parties or actors who work together and they all reach consensus or agreement, then they can decide how to upgrade the system as well. And then the third approach, which is more unique to these rollups and certainly Arbitrum, because they have this on-chain governance component now. Could you bring in a DAO, which is basically saying, can you have an entire collective of token holders, which could be thousands of people, reach consensus and agreement on how to upgrade the system? Now, what's important there is that once you have a DAO in place that can make these decisions, they can also make decisions around different types of authorization. So, for example, maybe the DAO is ultimately responsible for, authorizing an upgrade to the system, but they can also appoint a security council, which is a multi-sig of 9 out of 12 people who can step in when there's an emergency or when there's not an emergency in order to upgrade and protect the system and to fix bugs very rapidly and quickly. What's really cool about this entire process is that it's transparent and that anyone can see those tiers of authorization and, of course, the responsibilities for each party as well. So that's probably a long answer to basically saying, I don't myself believe that we should ever get rid of admin keys per se. I think what's important is that it's transparent and that the DAO or the ultimate form of governance, the social consensus, can reach agreement on what that should look like. Because I think for my philosophy anyway, when we consider the rollups as a software stack, the idea is that 99.99999% of the time, the software will run autonomously and it will protect users of the network. It will protect the funds held in the bridge, billions of dollars. The software will enforce the rules and protect the users most of the time. Then 0.00001% of the time, you need some form of human intervention, either to propose upgrades to the software or to step in and fix bugs when there's a really dangerous bug that's discovered. And this isn't actually very different to like Bitcoin or Ethereum. The only difference now is that governance process and the parties responsible for that is explicit. It's very transparent. We know exactly who should step in at the right time to do the right thing. Where on Bitcoin and Ethereum, they rely more on rough consensus. They don't really want to define the process because they want to defend against governance attacks. And so we saw recently with on proof of stake Ethereum, the part of the proof of stake protocol broke down, the finality gadget broke down because of the Prism client. So Prism had to stand up, get up, fix their bug, and then redeploy that. So even in these live layer 1 networks, we have at times where humans have to get involved to fix bugs, to protect the system. And I think for rollups, we're going to still need that as well. It's just about defining the right process so we know who those people are and hold them accountable to it as well.
So we have walked through all the three topics. So I think it's almost time. And this is about the overview of decentralized rollup. So we didn't go into too much the like sequencer and prover network and data availability problems. So I think we will have more podcasts about this topic. So I think I really learned a lot from this talking. So thank you again. And I believe our listeners or readers can also benefit a lot from all of this. So thank you, Patrick, and see you next time.
Yeah, thanks for having me on. It was awesome.
Okay, thank you. Bye-bye.